11.3 is areas of polygons. So we're probably going to go over some of this more in class because it is part of it will be kind of new and different than what we're used to. Okay, so the first thing that we're going to talk about is area of rhombus or kite. Pretty simple here. If either one is just area is equal to 1/2. And then I'm going to write d sub 1 times d sub 2, and what that is the diagonals, okay? So you can see here that they've denoted d sub 1 and d sub 2 as those diagonals. So whenever I go to example 1, it says to find the area of each rhombus or kite. So in part A, area is equal to 1/2 of 8 times 6. 8 times 6 is 48. So 1/2 of 48, which is 24. And it would be meters squared because it is an area. Oops, sorry, made my box too small. Okay, the next one, part B, area is equal to 1/2, 7 times 10. So 1/2 of 70, which is 35 centimeters squared. Okay, all right, so this is the next part that gets a little bit confusing. It's not impossible. Okay, so it says the diagram shows a regular polygon inscribed in a circle. The center of a regular polygon and the radius of a regular polygon are the center and the radius of its circumscribed circle. The distance from the center to any side of a regular polygon is called the apothem of a regular polygon. The apothem is the height to the base of an isosceles triangle that has two radii as legs. The word apothem refers to a segment as well as a length. For a given regular polygon, think of an apothem as a segment and the apothem as the length. A central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices of the polygon. Okay, remember we learned that last chapter. To find the measure of each central angle, you take 360 and divide by the number of sides. So that's super important, okay? So that's the new part, right? So to find the central angle of a regular polygon, you just take 360 and divide by the number of sides. Okay, next page. Okay, so it says example 2. In the diagram, ABCDE is a regular pentagon. Okay, automatically I think pentagon n equals 5, or you can count it here in this picture. Inscribed in circle F. Find each angle measure. So the first one would be the measure of angle AFB. So AFB is the central angle. So you're going to do 360 divided by 5, which gives you 72 degrees. Okay, then the next one would be AFG. So AFG, so segment FG bisects angle AFB. So the measure of angle AFG is equal to 1/2 of 72, which is 36 degrees. Okay, part C, the measure of angle GAF. Okay, GAF. Well, I know that a whole triangle here, right? This makes a triangle. I found out that AFG was 36, and I know that this one right here is 90, so that leaves me with 54 degrees. Okay, so I know every angle now in that triangle that I outlined. Okay, all right. So then we're going to take that, and it's going to help us solve for the area of a regular polygon. So it says you can find the area of any regular n-gon by dividing it into congruent triangles. Capital A is equal to the area of one triangle times the number of triangles, okay? Or you can get 1/2 S times A, where S is the base of the triangle and and A is the height of the triangle because that's the apothem, and N is the number of triangles, okay? So that's where you get all of these letters from, okay? So then I can kind of reorganize some things, and I can do 1/2 A times N times S, okay? But N times S, the number of sides times the base of the triangle would just be the same thing as the perimeter. So that's where we get our area of regular polygon theorem from. So it becomes A equals 1/2 the apothem times the perimeter, which is the same thing as the number of sides times the side length. Okay. So again, n-gon, side length is S, 1/2 of the product of the apothem A and the perimeter capital P. Okay. So if I turn the page, okay, you're going to kind of get to see an example of each kind that we're going to see here. So it says a regular nonagon is inscribed in a circle with a radius of 4 units. So automatically I think that n is equal to 9. Okay. Then it says find the area of the nonagon. Okay, so what I see here is I know that I'm going to find the measure of angle JLK, which would be 360 divided by 9, and that gives me 40 degrees. Okay, then I want to know the measure of angle KLM, so I'm just going to take 1/2 of 40, which is 20. Okay, so then I'm going to draw this new triangle. It's not really a new triangle, but I'm going to just draw it larger out here so you can just see what I'm looking at. So I am looking at LMK. I know that this is a right angle, and I know that this is 20, and it tells me that this is 4. Okay, so I need to figure out 2 different things here. I need to figure out what both of these sides are before I can move on, okay? Because my x is going to help me find the perimeter, and my y is the apothem, okay? So I am going to do, from my angle 20, maybe I'll write this in a different color so it stands out a little bit more. I have O, H, and A. Okay, so then to help me solve this, I'm going to do the sine of 20 is equal to x over 4. Okay, so then you multiply both sides by 4, so 4 times the sine of 20 is equal to x. If you go ahead and do that out in your calculator, you should get 1.37. And I want you to double check that you can actually get that answer, because if you can't get that answer, then right from the get-go, we're having trouble. Okay, so we need to figure that out now before we keep going. Okay, so then I also can figure out that the cosine of 20 is equal to y over 4. So then 4 times the cosine of 20 is equal to y, which is 3.76. Okay, but now if I look up here, okay, I don't just need to know k to m, I need to know k to j. So I'm going to take kj and take 2 times km, which was x, which is 1.37. So that gives me 2.74. Then I'm going to take that and I'm going to find the perimeter. So I'm going to take 2.74 and multiply it by 9 because there's 9 sides, and I get 24.66. Okay, now I have the apothem, okay, which is y. Okay, I'm going to put a lowercase a right here so that you know that that's also the apothem. Okay, and I know the capital P, so then I can plug it into our perimeter, into our formula for area, which is 1/2 apothem times perimeter, or I always like to say 1/2 little a big P. Okay, so 1/2 little a was 3.76. Capital P was 24.66. Multiply all of that together and you get 46.36. And it just says units, so I'm going to go units squared. Okay, and that's how you would solve that problem. Okay, so there is one example. Now here's another example where they give us some different information. Okay, so it says you are decorating the top of the table by covering it, with small ceramic tiles. The tabletop is a regular octagon with 15-inch sides and a radius of about 19.6 inches. What is the area you are covering? Okay, so sometimes I like to make a little list over here to the side of everything that I need to know before I can be done. Okay, so I need to know N and S before I can find capital P, and then I have to know lowercase a before I can plug everything in. Okay, so if you notice, I can drop a perpendicular segment right here, kind of like what you saw up here. Okay, and if I'm looking at this, I know that P, I'm going to make this a new letter. We'll call this M. I know M to Q is 7.5 because I took half of the side length. Okay, so that's 7.5. So if I want to find what this apothem is, I am going to take a squared plus 7.5 squared equals 19.6 squared. You get a squared plus 56.25 equals 384.16. Subtract 56.25 and you get 327.91. Take the square root and you get x equals 18.1. Okay, so my apothem is 18.1. My number of sides, I could have filled that in earlier, is 8. I could have also filled in that the side length is 15 because I gave it to us in the problem. So then to find capital P, I do 8 times 15, which is 120. Okay, if you want to know, I got capital P equals 8 times 15, which is 120. Okay, so then I know everything that I need. So area is equal to 1/2, little a is 18.1, capital P is 120. Multiply that all out and you get 1086 inches squared. And that's your answer. Okay, so that's all the notes that you need. Let me know if you have questions. We'll do a couple examples in class.